Hi, I'm Amy Parsons, president of Colorado State University and host of the Next 150 podcast. We have so many remarkable people in our community, and this is where we're going to hear their stories. We're going to get their perspectives on CSU's next 150 years and gather their very best advice for today's CSU students. Let's get started, Rams. Hi, so today we're honored to have with us Dr. Sonia Kreidenweis. Welcome to the Next 150 podcast. Sonia, thank you for being here.
Thank you so much for the invitation. I'm so glad to be here.
Well, you are a very distinguished professor at CSU, professor of atmospheric science. You're in the study of atmospheric particles with your educational foundation from Manhattan College and the California Institute of Technology. You brought your expertise here to CSU in 1991 after positions at San Jose State University and consulting at the Lawrence Livermore National Lab. You served as the president of the American Association for Aerosol Research, contributed to the executive committee of the American Meteorological Society, and were honored as a University Distinguished Professor in 2014, which, as we know, is the highest honor we give to professors here at CSU, among many other awards and honors. But importantly, your exemplary contributions to engineering were acknowledged this year when you were elected to the National Academy of Engineering, one of the highest professional distinctions accorded to any engineer. So major congratulations on that.
Thank you so much.
It's a really big deal. We're really proud of that. Just let's stay with that for just a moment. What was it like for you to find out that you'd been accepted in the National Academy?
Yeah, I heard by email just a few hours before the general announcement, and I already subscribed to get reports and other announcements from the Academy. So I actually didn't open the email initially. And it was quite a surprise when I did open it and find out what it said. And I was just so grateful, thinking immediately about the people who thought enough about my work and my team's work to nominate us. So that was fantastic. And thinking about our mentors as well. And then finding out a little bit later with the general news that Professor Jorge Roca was also selected. So that was just icing on the cake.
Amazing. Yeah, he's an outstanding professor as well. Tell us a little bit what it means to you personally and professionally.
Sure. Yeah. I think one of the main things was thinking about what it meant to my team. Mm-hmm. Really, it's an award given to an individual, but it really reflects that whole body of work. And so thinking about my former students and my colleagues and collaborators, I hope that, it was as exciting for them as it was for me to hear about that. So that was fantastic. And again, thinking about my mentors, that got me to this place. Just, very grateful for everybody that has been there, from my earliest ones at Manhattan College through Caltech, as you mentioned, and then postgraduate. Professionally, I think it's going to be really exciting because I'm finding there's a lot of opportunities through the Academy to give back, a lot of service. To contribute to reports on current events and so on. And I'm really looking forward to being able to take on some of those.
Yeah. We'll get into your work here in just a little bit and what led to this. Do you have a ceremony coming up, an induction ceremony?
Yes, there'll be a ceremony in the fall that I will be attending with my husband.
Wonderful. Yeah. Well, congratulations. We'll all be watching to see up there. And again, we're just so proud of your work and to have you at Colorado State University.
Thank you.
So normally I jump in with a random question just to get to know you a little bit more, but I wanted to talk about your National Academy. So let's go ahead and do that. If you want to choose a chip out of our little bowl here.
Okay.
And we'll ask you a question. What number do you have there?
Number
2. Okay. Well, this is apropos because you just talked about your mentors. So this question is, what's one piece of advice that you've received over the course of your career that really profoundly impacted your life?
Yeah, I think one of the best pieces of advice with respect to research was that the most interesting research problems are always at the intersection of disciplines. So thinking outside the box, thinking collaboratively, working with others, and getting into those really interesting intersectional questions. And that's been, I think, something that I've tried to keep in mind and that I've really enjoyed the most during my research career. So,
did that advice come early in your career and help to steer you in the direction of atmospheric science?
It did, definitely, yes. In fact, I remember specifically one scientist just talking about that. And as he mentioned that, it struck me how true that was for atmospheric chemistry, especially. It's at the intersection of more traditional chemistry and thinking about what that means in the larger environment and atmosphere, and all the amazing questions that were coming out in the 90s that people needed to work on. So it's been a guiding light for me, I think.
Where did your inspiration to go into this field come from?
Oh, gosh. Originally? Yeah, that goes all the way back to my undergraduate. Yeah. I had two professors at Manhattan College, Dr. Lou Theodore and Dr. Joe Reynolds. They were very early chemical engineers thinking about air pollution control. That was just the beginning of the EPA and some of the air quality investigations that people were starting. And they got me involved in research as an undergraduate. And I think that was so exciting because I realized how my engineering, which had been kind of traditional, could be applied to so many environmental problems. So I was really excited about thinking more broadly. And then when I went to graduate school, that was in Los Angeles in the early 80s. And you just had to live there for a week or so to realize that air quality was a huge problem. And again, a lot of people just trying to begin to understand what was the chemistry going on, what were the health impacts, how do you model and predict it and help people make good decisions about how to mitigate it. So it was a really exciting time to get in that field. Very grateful to my mentors there, Dr. John Seinfeld and Dr. Rick Flagan, who got me into this area.
That's a beautiful testament to the power of undergraduate research.
Absolutely.
And interdisciplinarity, right? And looking
Yes.
at that from an early age. And now you're a world leader in this space. So that's a beautiful story. Let's talk about your research a little bit in your particular area. So bear with me as a non-scientist as I read what I think is your area of research. You focus on characterization of the physical, chemical, and optical properties of atmospheric particulate matter and the effects of the atmospheric aerosol on visibility and climate. Particular focus is the characterization of aerosol interactions with water vapor, and you do field studies in several U.S. national parks to establish the sources and characteristics of particulate matter responsible for visibility degradation, which is very interesting. And specifically, you're looking at the impacts of prescribed wildfires, right? So talk to me, a non-scientist, a little bit about when we talk about and think about aerosols. What are we talking about?
Sure. So aerosols are any suspended particles in air, in the atmosphere in this case. So even though they're not visible to us right now, this room has a lot of particles in it from various sources, from us speaking, just from the outside air and so on. With visibility, there's some days where they're very evident that they're there. I know from my home, I look towards the mountains and I can see if they're hazy or clear that day and get a really good idea of how many particles are in the atmosphere. So we can see that visually, and what's less clear is why they're there. Was it from a smoke event? Is it just background chemistry that happens here on the Front Range? We're heading into summertime, which is a time of pretty vigorous chemistry with all the bright sunlight that we get. And we'll actually form chemical compounds that will turn into particles in the atmosphere. So there's a lot of different sources. In the last decades, people have developed new ways to measure them, figure out their composition, and then from that go backwards and figure out where did they come from. So if you're looking to improve visibility, that is the first question. What is their source?
So your work in the national parks. Tell me a bit about that.
Oh, that was fascinating. That was so serendipitous. After I came to CSU, I discovered that the visibility branch of the National Park Service is located here on campus, on the Foothills campus, right next to my department. And they were just starting to get into their monitoring network where they were asking these questions like, what are the particles made of? How do we use that to figure out sources? And our group did a lot of field work with them, special studies to do a little more detailed analyses than you could do with monitoring. And so some of our data, I'm so proud, went into making the regional haze rule that's helping the U.S. roll back visibility, especially in national parks and protected areas, so that when you go there, you experience more natural background conditions. That's the hope.
So tell me more about that, the haze rule. How do they do that? What are the biggest levers that you can pull in order to make a difference?
Yeah, that's a really actually great question because the levers that we can pull are usually the man-made ones. So we know if there's industrial pollution or pollution from things like transportation sources. We've done a great job in making all of those sources a lot cleaner over time. And it's been really interesting to see the evolution in their monitoring network. They have data that show how much visibility has actually improved in the several decades I've been working on this. So that's super rewarding. But there's a lot of natural sources. You mentioned wildfires. So that's one that's been in our minds, especially out west here. Wildfire season is coming up. And even when we don't have fires close to us here physically, we can often get smoke from distant regions coming and impairing our air quality. So I think globally, there's just been a lot of attention to the role of fires and how that may increase in the future. So it's hard, again, very hard problem to mitigate. But people may be aware of, interest in clearing out fuels. As we've suppressed fires for decades, all that fuel has built up and made wildfires more intense. So there's a lot of activity looking at ways there to help mitigate what might be.
So forest management.
Forest management.
Right, sort of the preventative aspect of it, and then prescribed burns.
Right. Trying to use prescribed burns to keep the fuel loads down and do that in a controlled way so that they have minimal impact during that burn.
Yeah. So, I assume that some of your work is being used globally in places that are suffering from very serious man-made pollution, even more so than we have here. What does sort of the future of that look like in that work in order to mitigate some of these really serious, harmful effects globally?
Yeah. So I think, every region has a unique air quality problem if we look globally, except for fire is pretty ubiquitous, actually. People use fire for a lot of different reasons. But we can already see more attention being paid in other parts of the world to air quality and efforts being made to use some of what we've learned in the U.S. applied to other regions, but also they all have unique chemistry, air chemistry going on. And so I've just been watching some of those developments with a lot of interest, just seeing what people are discovering about the atmosphere.
Yeah.
Things are not the same everywhere.
And, I see in here that, you look at the effects of aerosols on cloud microphysics and precipitation and climate.
Yeah.
So can man-made aerosols have that kind of effect on precipitation? I know this is a big question, but how does that work?
They sure can, yes. Interesting thing that has been in the media that some people may have picked up on, the regulations around the kind of fuels that ships can burn have changed recently. And if you've ever seen a satellite image of a cloud deck, you may have noticed stripes in them that look like contrails within the cloud. Those are ship tracks because they come from the ship's smokestack. And so those emissions have always influenced clouds. And there's been some studies recently looking at how once the fuel composition changed, there may have been fewer particles in the air to affect clouds and had a consequence, therefore, on the cloud formation and the cloud reflectivity that people think that they can pick up in the signals. It's a really fascinating natural experiment that's happened over large areas of the globe. That idea has been out there a long time. And, as people think about ways to mitigate warming, one of them is to try to deliberately inject particles into marine clouds so they don't precipitate, they persist longer, they're more reflective, and that can have a cooling effect on the environment.
That's incredible.
So it really is an amazing idea. And to have this natural experiment maybe suggesting that some of that is feasible has been really fascinating. So. Yeah.
So is that type of work the future of your research? Where do you see sort of the cutting edge of this discipline going forward?
That's been super interesting. Our group recently has focused a lot on polar regions, another region where we have a lot of change happening very rapidly and where clouds play a really important role. Clouds in both seasons have different roles in the water cycle and also in reflectivity in polar regions. And we can have an impact where if there is, for example, less cloud cover, we may have more solar absorption and faster melting and just feedbacks that way. So we've been studying a lot about the particles in polar regions, a hard region to get to, hard to study. Particularly interested in biological sources of particles to that region as permafrost is melting and there's more biological activity. How are those particles perhaps influencing clouds? So there's a lot of interest in what's going on near the poles right now. It's a very immediate problem. So particles and particle aerosol research, I think, has been important globally for a lot of different reasons. They play pretty important roles.
That's fascinating. I imagine that, we're an institution of higher education. I imagine there's a lot of students who are coming to us that want to get involved in this type of science and this type of research, even undergraduate students coming in because they're looking at a lot of these big issues and how they can play a role in some of the solutions to these big issues and climate and weather. And that's really what you're doing. What advice do you have for young people, students, even undergraduates at CSU and other places who are interested in this, how do they start down this journey of becoming a scientist like you, who's really working on important solutions?
Mm-hmm. There's a lot of opportunities to do undergraduate research. You mentioned that before. I think that is an excellent thing to encourage people to get into. And they're not always posted. Sometimes just saying you're interested to a faculty
That's good
member.
advice. Yes.
They can find you a spot in the lab. And when we have undergraduates come into our lab, we invite them to our group meetings so they can hear a little bit more about what everybody is working on and start getting that big picture. And I think something really important to remember is that almost any field can contribute to these problems. I mean, they sound very technical, and my interests are more on the technical side, but there are a lot of aspects to these issues that everybody can contribute to. So
Yeah. I mean, CSU has one of the best atmospheric science programs in the world, always nationally ranked very high. What advice do you have for us as a university, for me, in order to really keep CSU at the forefront of this work that you're doing?
I'm glad you asked that question.
That's a dangerous question sometimes to ask you. What advice do you have for me? What can I do? But I think it's really important here.
I do as well, obviously very passionate about it, but I also think it's been such a strength of CSU. I'm very excited about the climate initiative that has begun. We've always had great examples of School of Global and Environmental Sustainability touching on these issues and bringing people together. And the climate initiative, I think, is just a great way to think about bringing individuals from all these areas together and just amplifying the impact of our individual work. So they've been able to accomplish quite a lot, I think, in the time that they've had so far, focusing on one of our land grant missions around teaching curriculum. Some of the questions I think you were asking, how do students learn about these things? Trying to infuse that into different courses and giving them options for studying and learning more. But of course, there's practical solutions that people are thinking about that we just talked about, some of the solar radiation management, for example. There's adaptation. So some of the things that we see happening already, helping people in the US and globally understand that and adapt, but still so much research to go on. Climate system is pretty chaotic. We can think about the long term and where things are heading and how we might change that long-term trajectory. On the short term, that's really what people want to know. Shorter time scales, my region, my area, how will things affect me? So we don't have good predictability yet there. People are working on those questions. Super exciting. I don't work in that area myself, but I'm fascinated by what's going on there. So there's always lots of research to do. And keeping CSU the kind of environment, I think, where people are encouraged to think out of the box and work collaboratively and across disciplines, I think will really keep us in the forefront of that.
I feel like CSU too, we also are, and I think will continue to be in the forefront when it comes to democracy. And, we're just wrapping up. We've had a thematic year of democracy this last year, but really democracy is a foundational pillar of Colorado State University and our land grant tradition, right? Looking at the democratization of education, of producing students who are ready to be good citizens in the world. And I'm wondering, as we think about democracy, what are your thoughts on the role of democracy as it comes to environmental policy and environmental science and the things that you're achieving out there in your college and discipline?
Yeah, I think that's a wonderful question. When we launched the thematic year, I had a look at some of the principles that were put down. And the first one was individual participation. And that one really speaks to me. I think we're seeing that so much now, people wanting to understand more about what's happening with the climate. How do I get involved? It's that two-pronged approach. We need to take collective action. Each of us has a role to play, but there's individual actions too. People making good choices and thinking about what they might study and where their career might go to contribute, for example. So I think that's, as one of the principles of democracy, I think that one is really key. And I think about in my own work, I mentioned when I first got started, environmental regulations were just beginning to be formed. People were just beginning to look at that as something to be worked on together. And there's been so much progress. The air quality in the United States is really, truly amazing. I remember it differently growing up in New York as a kid. When I think about the differences now, we've achieved so much. And so when we get that individual will together, collective will, working with our legislators and with the science to back things up so we can make informed decisions, I think that we're going to be able to affect the change in the world that we really hope to see.
Well, I hope that we are the type of university that when we produce students with their degrees, they have a good understanding of democracy, their individual role in it, as you said, and the environment and sustainability and the role that they can play, right, in working on these problems, whether they're scientists like you or they're citizen scientists, right? I mean, this is the kind of thing that everybody can get involved in. I was thinking about you, Sonia, and your work that you did, especially in the national parks. I imagine that you and your particular area of expertise, when you're out in the national parks or maybe just out anywhere and you look up at the sky, you are thinking about different things than 99% of people who are looking up in the sky. What do you think about on just like a normal day, or you're out on a hike and you're looking up? What are your thought processes? What are you thinking about when you're out there? Because you have such a unique and amazing expertise in air quality and aerosols. I'm just interested in what that's like really for you.
I want to assure you that I really do appreciate the natural beauty itself, and I love seeing the scenery. But I will admit that I always take a look to see if I can guess what the particle loading is in the air.
That's what I thought.
And I often come back to my laptop and see if there's been a fire somewhere, or we get dust plumes from, I've seen a dust plume from Asia hit Colorado. Oh, wow. And it's just fascinating to go back to the satellite imagery and realizing that that's what you saw. So satellites have really opened up so many worlds to us to just see that big picture. And I do admit I like going and checking it out.
Oh, I'm so glad I asked that question. Are there things that you feel like the general public who are not in this field maybe don't think about it very much, ought to know on a day-to-day basis, or small things that they ought to be doing or thinking about as they go about their days?
Yeah, I think that's probably quite a challenging question. I think everybody has something to contribute. I do think there's been a lot of attention on air quality now, and I think that's really good. And not just outdoors, but indoors. Just thinking about your environment and how you're controlling many of the things in your environment. Indoor air quality, we have a lot more control over. So thinking about when a wildfire hits, how to protect people from breathing the smoke, for example. So there's lots of resources on the web to learn a little bit more about that. I know the city of Fort Collins has quite a bit on indoor air quality, so people can think about the health of their homes as they think about the health of the environment as well. And I do think people are attracted to Colorado because of its natural beauty. And there's such a passion here for preserving that and cherishing it. I do think many people have that in mind as they enjoy all the things Colorado has to offer.
Yeah, which is so much, right? Yeah. I mean, Colorado is just such a wonderful place to be and to focus on these issues here. And this has been such a great conversation. We've hit on so many different priorities of Colorado State University, right? And the pillar of democracy we talk about, and research, the power of undergraduate research, which I'm a huge believer in. And I think that it really adds the value of the college experience overall, that it's not just the degree that you get in order to get the job immediately afterwards. It's all the experiences that you have at CSU along the way, which help frame how you think, how you approach issues, where you go down the road. And being part of research here at CSU is a huge part of that. And of course, for me, it all comes back to our number one priority is student success, right? It's getting students to CSU, getting them inspired on their passions, and providing that value and that valuable degree. So as we wrap up, my final questions always come back to students. And obviously, we'll have a lot of students who will look up to you as a leading scientist, as a female leader in your field, and as a National Academy member, which is amazing. And so if you think about what advice you have to students who are just starting their academic journeys at Colorado State University, what would you tell them?
I do have some advice for them. I think number one is thinking about finding mentors. So important in my own career, my own life. There are so many people out there willing to help you, and people need a network of mentors. That you have cheerleaders in your life, you have people that you go to for advice, and other people that just help through difficult situations. And so everybody needs those mentors, and looking for them is one of the things that everybody should do. They will be some of your professors here. One of the reasons I'm here is because of that culture that we have, wanting to support our students, wanting to support their success. I also say, don't be afraid to ask for help. And then finally, don't be afraid to fail. If you're not failing once in a while, you're probably not challenged enough. Yes, you've heard that saying before. And I think it is something to just keep in mind that that's part of it. And those are all learning opportunities. There are, as you said, there's so many things that CSU has to offer, both in the classroom and outside the classroom, things to be involved in, and take advantage of that while you're here. It's an amazing place, and it will give you amazing education and open opportunities you never really thought about.
That's great advice. All Rams listening, I hope that you take that advice. Find your mentors. Don't be afraid to fail. Get active. Be proactive, right? Looking for those opportunities.
Yes.
And if you have the chance to get involved in undergraduate research somewhere along the way, don't miss out on the opportunity to do it. That's great. So thanks for that wonderful advice for all of our students, which is actually great advice for everyone, I think, whether you're a student or you're not a student. So again, congratulations on National Academy. And we're just so proud to have you at Colorado State University. And thank you for the incredible research that you're doing that has a meaningful impact here in Colorado and around the world. And we look forward to seeing what you do next.
Thank you so much. And thanks to CSU for all the support that I've gotten over the years. I wouldn't be here without it. And thank you for having me.
Yeah, thanks for sharing your time with us today. All right, that's Dr. Sonia Kreidenweis on the Next 150. Thanks so much for being here. Thank you for listening. I'm Amy Parsons, president of Colorado State University, and you're listening to CSU's The Next 150, where we explore what comes next for CSU by chatting with change makers who are already leading the charge and shaping our next 150 years. I'm gathering their very best advice for today's CSU students. Stay tuned to wherever you get podcasts for our next outstanding conversation. Go Rams!